of glycine estimation, and the method is Sorenson formol titration. The first thing is you need glycine, you will block the amino group of glycine by formaldehyde and titrate the carboxylic acid group against sodium hydroxide. So when you add, to block the amine group of glycine, you add formalin solution. But because formalin can undergo aerial oxidation, so the formalin solution is first neutralized by sodium hydroxide solution. If formic acid is formed, it is neutralized by sodium hydroxide solution. You add to the formalin, pipette out 10 ml of formalin solution. To it, add 2 drops of phenolphthalein as an indicator, and then titrate it against sodium hydroxide from the burette, and the appearance of the faint pink color shows the endpoint that the formaldehyde has been neutralized. See, this is the faint pink color that you can see, that obviously this is the endpoint of formalin neutralization. This neutral formalin solution will now be added to obviously the glycine solution. And before glycine also estimation, before you start estimating glycine, obviously you need to free glycine of the zwitterion. So, or glycine, to 25 ml of glycine also, you add 2 drops of phenolphthalein as an indicator and add sodium hydroxide. So automatically the NH3 plus, if any NH3 plus is formed, it will be neutralized. So you will have the free glycine now. The amino acid, the amine group and the carboxylic acid group, both will be free. And now if you add formalin solution, only the amine group will be blocked, and you can obviously now titrate it against the carboxylic acid group, can be titrated against standard sodium hydroxide.
Now you are standardizing the NaOH solution.
But the first step of this is you have already prepared a neutral formalin solution. Now the sodium hydroxide, which is a secondary standard, has to first be obviously standardized against a standard oxalic acid solution that you will prepare. A standard oxalic, as all the strength of the solution, sodium hydroxide, oxalic acid solution, and also the unknown glycine, all have the order of n by 20. They are of the order n by 20. So you first, this is the first step that SK madam is performing, that is obviously the standardization of sodium hydroxide against the primary standard oxalic acid, which is n by 20. And you obviously you prepare the oxalic acid solution, weigh it out, prepare the standard solution in a volumetric flask, and then use that to standardize the sodium hydroxide solution. This is the end point will be pink. In the burette, you take the sodium hydroxide solution, because always you will use sodium hydroxide. So it is just in this case, it is reverse. You do not take oxalic acid. Normally we take acid in the burette, but over here the sodium hydroxide is taken in the burette, and the 25 ml of oxalic acid has been pipetted out in the conical flask, and to it 2 drops of indicator phenolphthalein has been added, and it is now being titrated against sodium hydroxide. You will repeat this titration for at least 2 times. When you titrate it at least 2 times to obtain the value, and you should see that the burette reading should not differ by more than 0.2 units. Endpoint will be pink. It is nearly end point is nearly coming to an end. Means the titration, that is, you are reaching the end point nearly, because you can see that the pink color is now lasting for more time than normally when you started the titration. The pink will last and this is the end point. This is the end point. With 1 drop you can see that there is a pink color. The pink color, the faint pink color, you will have to maintain this color. Remember, once it cannot be dark, once it cannot be light, you will have to maintain this color for the titration of sodium hydroxide against oxalic acid.
17.1.
So the burette reading shows 17.1. So you have used 25 ml of n by 20 oxalic acid, and for neutralization of that you require 17.1 ml of sodium hydroxide solution. From that you can calculate the strength of sodium hydroxide solution, and it will be of the order n by 20.